Good afternoon, ladies and gentlemen. We're about 5 minutes until the start of this webinar here, so we will just give everybody a few minutes to jump on. All of you who are on the webinar are in listen-only mode. If you did have a question, please use your control panel to send in a question via the question feature on the right-hand side of your control panel. Thank you. Once again, good morning or good afternoon, ladies and gentlemen, to wherever you are, to this Solid Mindshare series webinar. This is the second of the 3 webinars that Solid is currently hosting, and this webinar is hosting in conjunction with Thames IBLNet. We will go over some of the housekeeping items really quickly here, and then we can get right into the webinar. All attendees will be in listen-only mode. All questions can be submitted during and after the presentation via email at questions@solid.com or via your control panel on the right side where there's a questions section. Any questions that are not answered on this webinar towards the end of this call will be answered by close of business on Friday, October 28th. We'll get into the actual presenters and the topics here in a second, but again, feel free to submit any questions during the webinar or anytime after as well. So again, thank you for joining this webinar here. My name is Lakshmin Thiagarajan. I'm Director of RF Training and Design here at Solid. I'm going to be one of the presenters, and I'll really quickly also have my co-presenter introduce himself here in a second. Solid is hosting this webinar currently with Thames iBuildNet, Thames itself, which has been recently acquired by InfoVista. The topic we're going to be covering today is technical considerations for hybrid DAS deployments, primarily focusing on indoor-outdoor type, campus-type deployments. Again, feel free to submit any questions that might come up via your chat window. So right off the bat, really quick, my name is Lakshmin Thiagarajan, as I mentioned. Work for Solid. I've been in the DAS industry for a little over 9 years. I have been part of both an integrator and also an OEM. I've been part of both the post-sales and the pre-sales world of things. So I've really seen the DAS evolve from a very grassroots, passive type environment to an active and today to a hybrid type deployment. Solid itself does a lot of work all over the world with a lot of front-haul and back-haul solutions, which I'll get into here shortly. I'm going to go ahead and let Jim introduce himself as well.
Yes, I'm James Hefner. I've actually been in the in-building space for actually now 17 years from various facets. I currently am a senior technical sales engineer for the iBuildNet platform, which is a Thames iBuildNet, and we'll be reviewing some of that capabilities later on in the presentation. Excellent.
Thank you, Jim. A little bit about Solid for those of you who are not familiar with Solid. Solid is an OEM. We started off in 1998 back in Seoul in South Korea. We're publicly traded on the KOSDAQ. The 2015 DAS revenues a little over $270 million, and basically what we do is we keep people connected and safe in a rapidly changing world through a portfolio of radio amplifiers, RF radios and optical transport solutions through a densification network. We have deployed DAS solutions at some of the world's most well-known venues, such as the New York City subway, Daytona Speedway, McCarran Airport, and so on and so forth. We do a lot of front-haul and back-haul solutions for remote radio heads, and these all have been battle-tested by one of the world's leading operators in South Korea, SK Telecom, that has already been trialing a lot of 5G type deployments. Solid's incubating and innovating future solutions as well that are truly scalable and propose multi-purpose common infrastructures and trying to basically change the game by evolving and creating amplifiers that are smaller, lighter, faster, and more importantly, very efficient. What you see in front of you is a quick snapshot of our current portfolio. On the left-hand side, the EBIU, that's basically our head-end interface unit, which interfaces with small cells, base stations, repeaters, any RF source primarily, which feeds an ODU, which is an optical transceiver. And then we have a whole portfolio of remote units, the 1 watt, 2 watt, 5 watt, and 20 watt, to be able to address different market segments all the way from low power solutions to mid power to high power solutions. All of these remote radio heads or remote units can basically run off of the same head end. All these remote amplifiers are multi-technology, multi-band, they're carrier agnostic. So depending on your needs or your use cases, you can simply select the card of the head end and select the card of the remote end. So we're completely modular end to end. And they give you a lot of flexibility in being able to deploy these solutions. We are a little over 1,200 employees globally, and our core business is RF amplifiers, with most of our R&D and manufacturing in South Korea. In the U.S., we have existed since about 2009, so we're running about 7 years right now. This is a teaser for those of you who are familiar with Solid. This is a very, very preliminary spec at this point. What we're trying to also do is continue to evolve, as I mentioned earlier, and one of the common feedback that came out from the industry was about higher power amplifiers. So Solid is working on potentially coming up with a 40 watt amplifier. This might be a lot of exciting news for many of you who do outdoor type or campus type deployments. You would be able to sort of mix and match the 20 watts and the 40 watt amplifiers within the same chassis. And since this is in very preliminary stages, we would love to hear your feedback and your needs as to being able to utilize the solution and what sort of additional feature sets that you would like to see in this product. So more to come on this one. Stay tuned. This is, as I said, just a small teaser. It's the first time we have publicly shown this. So you certainly will continue to hear more about this as we go on. So really getting into the meat of the presentation today, understanding how to deploy hybrid DAS and what are some of the considerations we need to kind of pay attention to. Obviously today DAS has become a very complex ecosystem where there's different needs from addressing the capacity, addressing the coverage, understanding aesthetic concerns, understanding the amount of power needed, space. So all of these concerns really go into when a design engineer starts designing a DAS on paper, to be able to take all of this into account and not just simply look at power levels. So there's a lot more that's going on in today's world, and one of the reasons that we're looking into hybrid DAS today, which have been much more cost efficient, is in some of the things that we have learned over time. So let's talk a little bit about and understand some of the systems today and how they're basically set up. So in order to visually kind of understand it, here's a sample, and this is courtesy of Omnitron. Here's a sample of a university campus where all the purple or blue nodes that you see are basically outdoor nodes. As you can see, they cover a pretty good swath of the campus itself, but there's still a lot of coverage holes kind of pointed out by the orange or the red shading in some of these buildings. So while we have been able to cover a good portion of the campus, there's still a lot of gaps that need to be addressed. And as you can see at the bottom right, all the green is represented good coverage, the yellow fair, and the red in poor coverage. So one way to perhaps do this is, what if we augmented this existing outdoor DAS with some indoor nodes? And that's what this next slide kind of shows you. So all the little orange dots that you see have been indoor nodes augmented inside of buildings. As you can see, in a very typical campus environment, there are a lot of buildings that are very small to medium size, barring maybe a large stadium like this. So in order for us to go ahead and put in an indoor node in every one of these small buildings or medium buildings might be cost prohibitive. But if we were able to kind of mix and match it, where we were able to cover some parts of the campus with outdoor nodes and some parts of the campus with indoor nodes, it really will make your solution kind of seamlessly transition between traffic and also from a cost standpoint. So as we start to see more and more of these multi-building campus type environments, the hybrid DAS approach seems to be the most effective from a lot of different scenarios, and those are some of the things that we will kind of talk about right here. Okay. So why did hybrid DAS to begin with? So multi-building campus environments, as I just mentioned, has a large mix of small, medium, and large buildings. This is very, very true in campus environments, whether it's an urban or whether it's a rural campus environment. Deploying an indoor DAS may not always be the most cost-effective, simply because, I mean, in a lot of these buildings, which are typically decades or a few hundreds of years old, especially in a lot of the older college campuses or university campuses, there's not a lot of space in these small buildings, and then for me to put an indoor remote in every one of these buildings might require a lot of them, especially large university campuses could have upwards of 50, 60, 70 buildings, and to put in a remote unit in every building and every floor may simply not be cost effective. Due to the highly transient nature of traffic, so an example would be students who typically are in the dorms in the evenings, but are in the classrooms during the day, and perhaps at the stadium during the evening, during the weekends. In order for me to simply crank up the power to cover every inch of the facility at every point all the time may not be necessarily very effective. So in order to increase the efficacy of deployment itself, and in order to kind of help model along with the transient nature of the people moving from location A to location B to location C, really mixing indoor and outdoor nodes will really help spread coverage costs, and you're going to really extract more bang for the buck. Now, having said this, Solid, we continue to build large campus environments with completely indoor DASs as well. We're covered campuses that are 13, 14 million square feet that are completely indoor covered. But a lot of reasons why certain campuses are covered a certain way. But again, Jim could talk to you a little bit more about some of his experiences as he shows you a demo later on in this presentation about a couple of campus environments where they were looking at a mixed indoor-outdoor, and that saved them millions of dollars in terms of the deployment itself. So in order to truly extract more bang for the buck, it makes a lot of sense to actually do a hybrid DAS approach. Combining the indoor and outdoor coverage enhancement will simply make it more efficient. And, sometimes this might just be the silver bullet that you're looking for. We continuously have a lot of challenges, which again, to be very candid, we will talk about. No solution is going to be beset with no problems at all, right? I mean, we're always going to have some challenges we have to overcome. So we'll talk a little bit about that. But in general, overall, when you're combining an indoor-outdoor coverage enhancement type solution, and partly, an OEM like Solid, for instance, or any OEM that has a mixed portfolio of low-power solutions, high-power solutions, medium-power solutions, can really help drive that architecture very seamless. So to end user who sits and manages and maintains the system, he or she can truly be able to actually manage the system regardless of where the node is and regardless of what the power is from a centralized location. And simulcasting. Most design engineers, or in fact all design engineers, and some of you may be on the call as well, you probably take advantage of simulcasting all the time. So even in a mixed indoor-outdoor type environment, simulcasting can help reduce the overall cost of deployment. So if you have a building that's pretty wide, and you put an outdoor node just out on the, let's say, on the east side of the building, the west side of the building may not have full proper coverage, but for those you can augment it with a simple indoor remote unit rather than have to cover every floor, every inch of the building. So now you have truly simulcasted from the same sector by covering the indoor building along with the outdoor node coverage itself. And obviously, when picking an OEM, you also want to make sure that you're understanding the needs of the physical needs of that product, because being an outdoor node, it has to weather the elements, whether it be heat, like in Arizona, for instance, or a lot of rain, for instance, in Florida. So these things also go a long way to understanding what kind of product that you pick before you actually do the design and the coverage propagation modeling itself. So I talked a little bit about the challenges, right? I mean, this was just a little idea of we're saying, hey, this is the best way to do it. This is a great way to do it. This is a very cost-effective way, simply because we have done it. We at Solid here have learned over the years, have done a lot of modeling with both only indoor, only outdoor, and combined indoor-outdoor. But it's not bereft of problems. So let's look at some of the challenges of the outdoor environment itself. Number one, this is very, very basic, but it's also very most common. The availability of fiber, power, and space, or pretty much the lack thereof. Most cases, you don't have fiber running out to all parts of the campuses. There's no power, definitely, and space is also a big concern. There's a lot of these issues that we run into over and over again, and there is no single solution for this. Every project's different. Every project's a prototype. So we continue to work through these and try to address some of those concerns before, obviously, the deployment itself. Aesthetics, another huge concern. Most people here who are on the call who are part of a venue owner group or who own venues or part of that team, aesthetics is probably huge for you guys. From an RF engineer standpoint, there's a perfect location to mount an antenna or a perfect location to mount a remote unit. But at the end of the day, that's never, typically never the case, because you can't simply mount things wherever you want it. So whether it's boxes, antennas, because of the presence of these devices or units, it's always going to be concerned. The venue owners always ask us to move these things to different locations. And then again, you also have, when moving to different locations, what about risk of vandalism or maintenance access? Sometimes it's really nice to hide something away in a corner part of the campus, but if it's so hard to get during maintenance or any sort of replacement needs, it's going to be very expensive or very difficult for an engineer to be able to get to that point. One anecdote I can think of is we had deployed a solution in a university a while back, and because the university was concerned with vandalism, what they ended up doing was they actually started building metal cages around every antenna in that facility. Now, from a true, logical perspective, that really makes sense. But all of you, from an engineering standpoint, you probably understand this. About 3 months in, we got a lot of calls saying the system's not working. We had a lot of problems with it. And guess what? A lot of PIM, passive intermodulation, for those of you not familiar with it, by building metal cages around RF emanating elements is probably the biggest no-no that you can ever run into. So it was something that, some of us obviously laughed at it, but obviously there was a big concern about education in the industry, understanding, why you shouldn't be doing things like that. And at the end of the day, trying to create that balance between making the venue happy versus making the operator and the OEM and the coverage folk and the people who need coverage also happy. So it's these things that we constantly battle, and we continue to battle. And I don't think there's ever going to be a fixed, bullet proof way to do these things, but it's about understanding the environment, understanding the education behind it, and continuing to help people do the right things. Interference, pilot pollution is the other challenge we run into a lot of times. Again, macros have been built out. I mean, people are adding more and more towers. Coverage down tilts are being changed, antenna down tilts, in order to provide the different coverage aspects, changing the main lobes. But what that can do from an outdoor standpoint is if I need only 5 watts of power to cover, let's say, an open area of a campus, but because the dominant signal from the macro is so hot, I might now need to go with a 20 watt or 40 watt remote just to overcome that macro. So it could obviously add cost to your deployment, could add more power requirements, fiber requirements, all of that. But on the flip side, by putting our remote nodes and our antennas at a much lower rad center as compared to the macros, we will still be able to create that sort of spotlight effect. But you need to be aware of the fact that a lot of times we're looking to get 6 to 8 dB dominance over the outside macro. That can obviously add all these costs as well. MP concerns, maximum permissible exposure. Again, the idea of getting the coverage closest to the user, the end user, is great. But at the same time, we've got to deal with the fact that now if I'm using a 20 watt or 40 watt remote just to overcome the macro, I've increased that amount of exposure to the end user in a significantly higher manner. So it's something that we have to, again, battle and trade off. One of my mentors says this very, very well. There's no free lunch in the physics market. So this is exactly it. I mean, you could try to meet, swinging too much one way or the other could cause concerns on the other side. So being able to balance that between the coverage, between the type of remote units, between the exposure and aesthetics, and these are all some of the biggest challenges. And last but not the least is zoning and permitting. Obtaining right-of-way access can be significantly arduous process. If it's a university campus and if it's owned by, let's say, multiple entities, or multiple entities have right-of-way, you guys probably know this very well, that it takes a lot, from paperwork standpoint, from a process standpoint, and simply financially. So we could really drown ourselves in trying to get, even though this might be the most efficient method from an RF standpoint, if we lose all the money that we saved by doing an indoor-outdoor hybrid environment, hybrid deployment, by all the zoning and permitting, at the end of the day, is it worth it? So being aware of all these concerns is going to be very, very important for anybody to understand before you start deploying. And that's why today we have software tools, for instance, like TenZygoNet, which can really help model these things and on the fly be able to change locations of nodes, locations of antennas, or types of antennas, to be able to say, hey, you know what, if the venue does not want something here, we can try to remodel it and look at what the coverage is going to look like. Gone are the days when we were sort of simply going by best estimate or best efforts. Today we have a lot more ability to be able to do these things. So I think we've learned a lot of lessons, and some of those things I kind of want to quickly present to you guys. Manage the overall deployment cost by covering buildings from the outside in and then filling gaps with indoor. Again, it goes back to the fact that you don't have to plug a hole into every indoor building, but actually kind of manage it both from an outdoor-indoor standpoint. Novel concealment options for aesthetics. A lot of people may be familiar with the company ConcealFab. Another company is 3M, the same guys who make your Post-it notes. They make a lot of very good reflective paint that is not RF affecting. In fact, I'll show you on the next slide a couple of pictures of these shrouds or aesthetics. So being able to circumvent the issues or concerns by the venue. So these days we're that much more able to put our antennas where we want them, even though the venue said you can't, because we're able to hide them or conceal them. So we're getting around certain aspects to be able to not sacrifice coverage, but at the same time also meet the venue's requirements. Benchmarking and optimization. This is always recommended. Very often benchmarking is not done, partly because it's expensive, it's time-consuming, it requires a lot of coordination. But in order to be able to truly design correctly and deploy and optimize efficiently, benchmarking and optimizing for the entire campus environment before we actually deploy or even design is always highly recommended. In fact, should be the right way to do it. But a lot of times we go in quickly, we want to cut short the cycle of the project, and then we're spending a lot more time on the back end trying to optimize these things. So if you have the effort and the budget for the benchmarking, that definitely would be the right way to do it. Flexibility with antenna tilting. I talked a little bit about optimization, right? I mean, we've done tons of projects where we've done all our homework up front, did the design, did the deployment, only to go find out that something, the macro environment has changed, a new building has come up right between our antenna and line of sight of the building we were trying to cover. So things change on a constant basis. So as long as we have the ability to, simple things like using antennas that have good tilts, left, right, top, down, it gives you the ability to, again, optimize these systems efficient. I've been part of many projects where we didn't think of these things, and then we were stuck having to go ahead and replace the antennas, put in new lifts. Again, much more expensive process. Again, making sure you select a robust product with high MTBF, mean time between failures. Most OEMs will publish this MTBF data on their spec sheet. Just for reference purposes, solid remote units are about 10 years MTBF. We are completely IP65 rated, outdoor rated, so we have, for instance, you heard me say earlier about Daytona International Speedway. Our remotes are some of the cleanest in that project because they continuously get watered down and washed by all the rains that roll to Florida all the time. And they continue to work. Same thing with Arizona. We have our remotes mounted at the Phoenix International Speedway, where temperatures can really push 120 degrees Fahrenheit. They're really pushing the limits of the system. So again, making sure that you're picking the right product that will not simply give in because of the elements is also very, very important. You could do it all perfectly, but if you got to keep going, replacing a part and replacing the unit all the time, it's going to cause a lot of concerns. So we'll transition a little bit here into showing you some of these aesthetics that we have, either run into or some from some of our partners in the industry. So what you see here in the middle is actually a picture from Daytona International Speedway of our remote units mounted on a pole right pretty much in the center of the track. Here's another one from another site. As you can see, kind of pretty much concealed with this part of a tree where you can see all the panel antennas. Some of these might be macro, some of these may be DAS related. This one wasn't a solid project, so I can't comment on that. Here's another one where you see a remote radio or perhaps a remote unit with an Omni antenna on the top of this light pole right here. Here's another one where these looks like little smokestacks, but they're actually intended to shroud the remote modules and the antennas as part of a campus environment. On the top right is a pretty common one that you might see in the sort of southwest states of New Mexico, Arizona, where the cacti actually are not real cacti, but actually just shrouding the antennas for the whether it was a macro node or whether it was for a DAS node itself. And this one I wanted to point out at the bottom right here is this is a 1x3M. This is their reflective film or reflective paint that they call it. So as you can see, looking up from the bottom or from the ground level, it pretty much blends in with the background sky environment. So you don't even realize it's an antenna unless you really look for it. So a lot of these novel options coming about, obviously helping us as DAS engineers to be able to still meet the venue needs from an RF standpoint. So just food for thought to be able to think of different ways to do it. Not all is lost. You're not forced or bound by it because the operator wants all the KPIs to be met, the venue wants all their aesthetics to be met, and you obviously want to make sure your system works. So it's a balancing act for sure, but understanding all these different aspects can really help speed along the process, and at least knowing what to expect is probably the most important thing, so then you can help solve those problems. And in short, in summary, before I hand it off to Jim, I just wanted to give you, again, our product has been deployed a lot, continues to be deployed a lot. One of the biggest things I want to point out is our 1% failure rate since we started tracking this in 2011. Because of our high degree of resilience and reliability of our product, we have less than 1% failure rate. We continue to, again, change the game in the industry in terms of our efficient and novel solutions, innovating. We're trying to build faster and smaller and less power-hungry amplifiers because we realize, it's not just about the amplifier working the way it should, but it's also helping save the environment by going green. So we continue to work on this, and we continue to innovate. So we certainly look to your feedback as to what new products and what new solutions that you guys need and want, so we can continue to build that. Okay. So at this point, I'm going to turn it over to Jim Hefner from TEMS, and he will, kind of go over a little bit about how we can do some of the modeling that we talked about, and also share with you the capabilities of the software itself. Right? So Jim, I'm going to give.
Okay. Okay. I'm hoping you can see my screen. Okay.
Yes,
Excellent. Okay, so at this point we're transitioning into the TEMS side of it with designing the hybrid DAS network using TEMS iBuildNet. First of all, just to go over some of our product portfolio, we have, the Thames iBuildNet, but we also have Thames Pocket, and in this, illustration here, you can see backpacks with several Thames Pockets connected up, and obviously we also have Thames Investigation and Discovery for other data collection utilization. As for Thames iBuildNet, we have several different components for it. There's a design and developed from the ground up for industry experts for indoor, outdoor, and indoor to outdoor and outdoor to indoor. Just like a lot of your macro engineers usually are concerned about, in-building systems that lead out or bleed out onto streets that can, out of concerns of potential undesired handoffs and so forth, you can now model some of that so you know how much does it actually leak out, as well as the scenario of if you're going to go wire a new building, you'll be able to identify how much is that macro already impeding prior to collecting benchmark data and so forth, or maybe potentially being able to just avoid it to some degree. We also have intelligent automated capabilities, which can help make the design process a little automated, as well as doing some automation for tweaking the layout, spacing of antennas, choosing and selection of couplers and splitters to balance antenna outputs and so forth. And then the last here is the end-to-end workflow management for cross-functional synchronization. And what that is that's our cloud-based approach. So yes, you have your design engineers that are going to be designing, the various facilities, but you're also going to have, want to have your project managers to be able to look at things from a high level, as well as be able to potentially bring up, some of the systems, and do some tracking. And it also has, database components and all of the other things that are kind of globally needed to look at, other than from the specific designs. And then obviously off to the left here you can see in reference to time savings for doing some of that design times, which can be a bit consuming. And then at the bottom is the accuracy of the modeling is much more accurate for within 5 dB 90% of the time to that location. For high-level campus approach, now this is something which Lexman has described to some degree, but just chime in on a couple key points. So yeah, there's the outdoor DAS and the indoor DAS, but for any initial network, the first thing you throw at it is high altitude macro sites to cover as far as you can, and then you permeate to lowering them and covering smaller areas for capacity needs. And when you get into the capacity, the campus scenario, now you're dealing with capacity driving your design, and the macro might be too high, covered too far, so that we're going to be focusing on the location of each higher power node to potentially hit a side of a building and cover that whole building instead of having to put antennas trickled down every floor. But as we go further along, we're also going to be running in the scenarios where some buildings are just too large, hitting it from the outside, from the side. It's just not going to penetrate all of the walls. So in those cases, then we leverage the addition of indoor solutions or high capacity event scenarios, like whether it be food courts or to stadiums, and you need a more indoor approach to model these smaller sector areas. So the hybrid of ODAS environment needs to be modeled, and that's where this can do the modeling, the propagations, and also some user simulations to depict what the user experience is before you send this off to construction. And iBuildNet will help encompass all of this. As for the demos, let me just jump over here now to jump into this specific one. This is a large city, so when it comes to the outdoor data, you can see a lot of the buildings modeled. And in this, where you see this specific grid, we have this building here in which we're going to be looking at. So first of all, I'll just jump to just a simple floor plan layout. Actually, this specific floor has no indoor infrastructure on it. We do have 3 nodes here actually for this one, and we'll just jump over to the 3D view. So for the modeling, this is, we've got, all of this city built, which is an intense bit, but it's actually data that can be pulled in from various outdoor data sources. And then we'll kind of rotate over to our building. You can see this building here, which is it's not a solid building. It's actually just modeled in wireframe. Oops, sorry. When we get in close, and we'll actually just throw in our, bring up our predictions. So I'll zoom back out for a second. So you can now see what our macro predictions are, and that's what's depicted by these floating nodes here. And then you can also see from the side how this is permeating in. As it gets lower down, it gets a little weaker, shadowed by the upper floors. If we go to those upper floors, and you can see that at the higher ones, it's coming in from the outer edge and propagating internally fairly well. As we go down, it gets a little darker and a little darker. But previously, and as you can see the tip of my cursor, you can see what those levels are. Now for the predictions that are created, these are modeled in a couple of different ways. So we have 2 different resolutions. So this here is the resolution for the indoor, and this is the resolution for the outdoor. Because when you're running, various predictions, one of the last things you're really looking to do is, run, a citywide prediction, with an RF level at every square foot. It becomes a little too memory intensive. So with that, we're able to adjust both the macro and give it to a relative bin size, and then also for the indoor, where you still want it to be, specific enough that it's granular and gives you very accurate data. It's able to be adjusted separately. So if we're doing just just the in-building, we can model that accordingly and scale it for the macro as well. We can also do it where running the indoor predictions can be modeled to where that leaks outside. And okay, and here. Okay. Now, in this here, I specifically just ran this, this specific region, not to kind of put it to everywhere, so that you can also, relate to that. Let's go back to bringing that in. So you can also kind of scale that out from your macro data. Okay, let's just see what else. Now, and another one I have here as well for the demonstration purposes as well. Now, if you're just looking, into your, in-building solutions and so forth, yes, you can model your indoor infrastructure, and you can pull it apart for your 3-dimensional interests. So if you want to look into it and see any facet of it, you can also then go through that with pinpointed accuracy as to where is, what's covered by what antenna and so forth very clearly. We are able to run, so we have, various predictions here as well to run whatever scenarios are needed, including simulations, which is a Monte Carlo simulation that can then address your uplink users. So in this case here, we'd have traffic map where for, we can model as many different, adding users and then all the various different user types. So for heavy download users of FTP, or you know, just simple things of web browsing or video. Obviously, video is going to be a more memory-intensive model. And then you can run whatever icon and then your numbers of users, and then leverage that to run simulations. And then it'll address your uplink and downlink and throughput and various scenarios for those. And then from those you can from these here you can identify how many different scenarios it wants to run in estimating those simulations, including what sources you want involved, you know, identifying your traffic map, so you have your user scenarios invested, including, you know, your potential interference, and then your displays. So all that can be get brought into this. We did run out a little bit of time for this presentation because we were going to run some outdoor simulations for this specific venue, but that became the time constraints became a little difficult for that this morning. But for this, we can always bounce back and forth and then identify just issues with regards to the building itself, and then just go back to the building. Now again, if I just want to focus on specific parts of that, so if let's go down to just go down to floor 10 real quick. Okay, in this case here, we're able to see the various, you know, the three different, you know, nodes that we have here. Obviously, I mean, this was just transmitter nodes for demonstration purposes, but you can actually pull apart your entire, you know, facility as well to see any details, whether you think, oh, something's missing or something's, you know, not as you wanted it, and you can, you know, pull all that apart per floor based upon the structure, devices, signals, regions. So in case that meant that I wanted to bring back in my, no, I believe it was the AWS band. Okay, we'll go back to that on here. So this is all the indoor leakage coverage. But as for how this applies with regards to, you know, your outdoor to indoor, you don't have a lot of limitations, where a lot of times before you might have, you know, your planet or so for your macro data usage, and then you might switch to you know, another tool for your in-building, where this can give you the option of you know, applying both to one solution. Now, just like here, you see a very big gap between these. That's just because this is estimated your like average mean sea level, and this is the elevation of this area. It just happens to be a higher elevation location. And when you bring in something with this much data, well, actually, it'll initially, my building shows up. The other buildings are loading at this time because it is a little memory intensive for projects of this size. But I guess that's the majority of what I, you know, was looking to present today, and we just kind of hop back to this here, and just to kind of jump into a little summary. Where when it comes to the balance between indoor and outdoor, there's been numerous systems where I know, at least in the Northeast, where certain marquee campuses have been wired for different carriers, where, you know, it's ranged up to like 25 million to complete the project, where they approached everything from the indoor model. And then later that transitioned, you know, pretty quickly to scenarios where you would approach your outdoor from, you know, more of an ODAS node. You don't want, you know, a bunch of macros all, you know, 3 blocks from each other, creating massive pilot pollution, where we'd find lower level roofs to still cover the small, you know, the few blocks that it's trying to target, and also potentially penetrate buildings from the side. And then after they're strategized and so forth, then the amount of in-building wiring that needs to be done can come down. So all of the costly, you know, cabling, or, you know, from the, you know, cable company's perspective, it's that last mile, which is always the highest cost one, which there's many more of. That part of it is able to be kind of controlled a little better by doing the hybrid. The mounting of boxes and antennas, well, you know, always kind of comes into play. You know, here it references zoning, right-of-way, MPE, and the macro interference. But there's, you know, also, you know, your first leg of that is, you know, your customer's willingness, as well as, you know, for the aesthetics. The MPE is just more of an absolute, you know, legality and safety concern. But all of these trickle down into real critical, you know, obstacles that we all deal with. The last being the, for the component part, you know, the mean time between failures is, you know, pretty much the metric by which most, you know, hardware products are measured, where, you know, Solid has excellent statistics, as well as with the low noise figure for doing those longer link budgets and so forth that come into play. And then the AGC factor for their guaranteeing power per band, which is, you know, a blessing for multi-carrier projects. So the software tools with iBuildNet, you know, help kind of give that environment, you know, to leverage these tools and give a full display of both of these scenarios, where you do have some outdoor, some located on rooftops or otherwise. And, you know, we can also model the macro that might be at the major road, you know, near the campus, and hit all facets of those, the macro, the ODAS, as well as the IDAS. Lexman, did you have any other points that you wanted to note?
No, thank you, Jim. I appreciate you sharing your valuable insights using Thames iBuildNet. There have been a few questions that have come through, so I'm going to try to answer them as much as possible, and obviously have Jim share his thoughts on things that's relevant to him. One of the questions I forgot to mention, one of the topics I forgot to mention earlier, is for those of you who are wondering about this webinar, and you know, if the recording will be shared. Yes, that's absolutely right. We will share a link to the recording of this webinar right after the call ends. So you can obviously view it later on or share it with your colleagues. So that was one question. The other question that came through was a little bit more detail around understanding what lower rad center meant to dominate over the macro signal. I'll share a little bit of a tidbit about what it is, and then since Jim comes from a carrier background, I can have him share some insights as well. So rad center simply means it's the height of the antennas or the center of radiation on the structure itself. So obviously, your macro towers have the antennas mounted, you know, pretty high up, 50, 60, 80 feet, whatever. But in these outdoor type environments, we're not mounting antennas that high, right? I mean, we are actually the radiation center point itself is a lot lower. So you're able to create a lot more dominance in that sort of spotlight area, if you will. Jim, anything you would like to add to that?
Yeah, actually, you know, so especially with campus scenarios, this is one of those features where, you know, the roofs that you consider, you know, isn't necessarily the tallest that's, you know, up on the hill. You know, it can specifically be that you use that, you know, that third or fourth story roof to where it aims into, and it, you know, the 6-story building that's across the, you know, across the way. So those are the things that help kind of minimize the bleed out and the pilot pollution further on, so that you kind of contain the additional interference that more closely located nodes are or create.
Got it. Great. Another question, Jim. This was addressed directly at Thames iBuildNet. Can Thames iBuildNet make indoor coverage prediction for land mobile radio, so P25, public safety?
Yes, it's down to the lowest band of public safety. I'd have to confirm exactly. I believe that they're now getting down to 100 megahertz, where I think we're down to 150. And that's actually being looked into be addressed. But yes, you know, it's at that point, it's just the difference of going in and, you know, if there's any newer band. But you know, the same public safety SMR bands have not really changed in, a while. So if there's any new ones, we can go in and add that as a technology and frequency band. And beyond that, it's within the engine that does the prediction models. It's within that wide band, which is I think 100 meg to 60 gig. It was modeled to include all bands of ITO.
Got it. Thank you. Another question, I think this is also regarding Thames IBelNet. What is the advantage of using Monte Carlo simulation versus FastRay?
Well, the simulation is separate from the prediction modeling. So in IBelNet, there's actually several different modeling options. It's under a hidden feature only because out of all of them, the one that is effective, which IBelNet uses, is effectively a hybrid of that has been leveraged from all of this analysis over primarily like the past decade, and so that hybrid is what we use, because of its accuracy. Now, as for the Monte Carlo simulations, most of these tools are very downlink driven. Their predictions are downlink only, where for the Monte Carlo simulation, for throughput concerns and so forth like that, you want to model just like we went through that traffic map, and you might have different users, doing different things and with different throughput demands. You then want that to be, or you would probably like that to be able to be modeled as to, if I have 100 people in this room evenly doing these, 20 each doing 5 different types of things, what is the likelihood of their throughput being X? And if I wanted it to be that level, what would I need to increase my capacity to? So you can do that both on the uplink and downlink. That's a component that isn't available by other tools.
Jim, today's your lucky day. I got more questions about IBelNet. Does Thames IBelNet include embedded antenna types, or can other antennas be imported in there?
Oh no, yeah, it's it has a component database that it has indoor antennas, outdoor antennas, multi-beam antennas. So it's in one specific case. I know I was requested to use a very specific model antenna, which was a multi-beam antenna, because a potential customer wanted to ask or wanted to have us model similar to a design that they had looked at in a similar way. So we went to that antenna manufacturer and requested their data specs, created those antennas, and then modeled that venue with those antennas. So yeah, any antennas can be modeled in it. We don't have all of them currently, but we have many for most of the common applications, and are currently adding more and more of initially the more common ones that are known, and as others get requested.
Great, thank you. I had an easy question. This came in asking a little bit more about details of solid product and some description. That's a very easy one for me to answer. So whoever needs details about the solid product, just feel free to email questions@solid.com with that question, and we can certainly assign and get you guys the details of the product itself. I don't want to make this a sales pitch for Solid here, but feel free to shoot over if you need any questions on that. Jim, another question for you. Do you have any idea if other software, such as Atoll, can do similar kind of simulation as Thames IBelNet?
So actually, that's one of the key things is Atoll, we can export data from their database and bring it straight into IBelNet. Now, the key thing is, and this is where, the concern, most people would think then, well, why would they allow you to be able to pull in their data? And the outdoor data that we model for a given project does have a limitation. So it's not a market-wide, and that limitation is 40 square kilometers, which in the in-building world, that's absolutely huge. From a macro, side, that's a good size of a cluster maybe. So we don't fully infringe on their target market, and that's why, you know, we're pulling in the various tools like that, like Planet and so forth, so that we can pull in that data, and then you can build your you know, have your in-building view, and then kind of tweak the in-building to the indoor to outdoor side of it.
Thank you, Jim. Wow, questions are flowing off the chart for IBLNet. You got one more. Importing, I guess this is one big question. This has come up from quite a few people. What about importing data from VEX files and IBWave directly itself?
Yeah, so for VEX files, we do have a file type for our components, which is a DDX file. VEX files and DDX files are different file types, so we don't completely import VEX, and they don't, you know, import DDX. So they are different, but you know, they effectively do the same thing, which they are small files with product component information that's necessary to do modeling and performance accurately.
One more question around IBLNet. Which operators are currently using IBLNet?
Wireless operators. So we do have American Mobile. In the U.S., we are currently demoing with most of them. So you know, it's not approved yet, but that's something that we're looking to see change in the near future.
Great. Just going through the list of questions, folks. Just trying to see if we captured everything. I know some of you were wondering about the costs associated with that. I again recommend shooting an email to questions@solid.com so I can get the TEMS team directly involved to be able to reach out to you guys to talk more about costs and licensing and all of that. Another question came about. This is a very good question as well about Solid's components itself in TEMS IBLNet. So as Jim pointed out, the DDX files, we at Solid, because we are traditionally one of the early adopters of anything that's you know, exciting and new in the industry, we actually have been working with TEMS IBLNet for quite a while now. I probably want to say a good part of maybe a year or a year and a half. We have built all of our components in TEMS IBLNet today that you can actually design with, head-end, remote end. In fact, Jim, whatever propagation modeling he was showing you earlier a few minutes ago was actually using Solid components. So they're all available, and that would be, again, something that the TEMS team can actually share that with you guys. Jim, anything you want to add to that answer?
No, that was dead on.
Okay. A couple of questions have come about the recent change with InfoVista. I'm not sure what you guys can share or want to share, Jim or your team, about how that changes things or what it means.
I'm sorry, how that changes which?
Just about, you know, the TEMS, the licensing, and the uses of TEMS itself with the acquisition by InfoVista.
So it really is not going to, I mean, one of the key things with InfoVista, you know, and previously, you know, or so with TEMS is that there's not a significant overlap, so it's actually a very good kind of complementary offering. So we're currently, you know, like any merger, you know, working on ironing out, you know, different things, but there shouldn't be many significant changes. Leveraging whether it be an InfoVista, you know, sales point of contact or a previous, you know, the TEMS, you know, sales point of contact, I'm sure that'll either or would be sufficient, and they might, you know, direct you to the other, you know, for expertise factors, but beyond that, that'll be ironed out over time.
Cool. Thank you, Jim. Another great question about training. So I'm going to address training both from Solid standpoint, and then I'll let Jim address training from TEMS standpoint. So Solid has a lot of DAS training courses, some online, some in person, where it's comprehensive. We not only teach people about our product, we also teach people about the DAS industry, about RF engineering, about design engineering. So it covers the gamut of the whole sort of length and breadth of the industry itself. So if you needed, again, further details or perhaps opportunities to attend those classes, feel free to shoot an email with your contact info to questions@solid. And as far as training on Thames IBLNet, Jim, you want to take that?
Yes. So at this moment, there is a initial online training that can be obtained access for, and that walks a user through it. And then there is also a in-person training session that'll help kind of dig deeper and get into all facets of all of its capabilities. And that's based upon need as needed.
Great. Right, I'm going to pick a couple more questions before which we will round up. Obviously, our top of the hour here. About Thames IBLNet, is it only a prediction tool or can be used for real-time propagation as well?
Well, okay, I'd have to ask, what real-time propagation, because at the end of the day, it's going to be the modeled antenna based upon per degree expected gain values of the antenna, aimed at the exact direction that was set in the software. Now the problem then is, now you go out to the real world, you need to make sure that your contractor, find out what means they did for aiming that antenna correctly. Did they? Is the ERP what it was supposed to be? I mean, there's a lot of other things that kind of, prohibit it from being real time versus a modeling tool. It models it so that you can decide that that is the design you want, and that it'll live up to certain performance expectations before you hand it over to construction. The biggest part of that is you don't want to have to, it's kind of like a question of when you're doing an in-building design and you're on a given floor and you're kind of hesitant. Ooh, do I put 6 antennas or do I put 7? Normally the answer is, if you're hesitating, the answer is 7, because you don't want the cost of having to go back. And that's the key component, the slight additional amount. If it's on the fringe, you'd rather that if over time there's a little more interference or something, that you have some more dominance. So I would say it's a design tool. It's also you can run simulations, so that can help you from your expectations of it. But the real-time factor depends on what actually got deployed.
Right, I'm going to take one last question before which I'll go ahead and wrap up. So this one is asking about Thames IBLNet supporting other manufacturers outside of Solid as far as the components go.
Yes. Yeah, so just like you would kind of, expect for, let's just say whether it's integrators or so forth are looking for a design tool, they're going to want to be somewhat, product agnostic. If this was a Solid only tool, well, then Solid would probably want to put in some other components as well, to some degree, so that it's advantageous for their potential customer base. So yes, it does have others. But we've been working very closely with Solid to make sure that we have their components, and currently we're actually upgrading some of our component database so it can model their components even better, because of the relationship that we have so far.
Great. Thank you, Jim. As I mentioned, all those questions that we could not get to, we will certainly get back to you by the close of business on Friday, October 28th. If you have any additional questions, again, feel free to email. You see the email address on your slide right now in front of you. The last of the 3 Mindshare webinars is coming up on November 9th, Wednesday. The topic is Public Safety DAS, a new imperative for building owners, from 2 to 3 Eastern. Again, that's the last of the 3 webinars that Solid Mindshare is hosting. Its title is Public Safety DAS, a new imperative for building owners. All the details are available on our website, so should you want to register or sign up for that. With that, we can the conclusion of this webinar. Jim, thank you so much for your expertise and your insights.
Thank you.
And all of you on the call, thank you so much for your time. We certainly look forward to hosting another session sometime in the near future. And if you have any specific topics you'd like to listen to or hear about, feel free to send them in as well. Thank you again, and have a great week.